but I want to get you in the habit of what's going to be expected for the proofs. So here's the deal today. All those vocabulary terms we learned in Unit 1 ain't going anywhere. I promised you that on the first day of the Unit 1. They ain't going anywhere. So that could create an issue with a few of you in here who still don't understand them. Supplementary, vertical angles, linear pair, perpendicular, bisector, midpoint. They ain't going anywhere. Either we know them or not. We don't. All right, you, to bring it down to your street slang, you are cooked if you cannot, or if you do not know those vocabulary terms. There's no shot you'd be able to be successful. No shot. And you'll see why in the first two examples. So here's what I'm going to do with you today. I will give you a diagram and a true piece of information. That true piece of information is probably going to have a vocab term, whether you know it or not. What I would want you to do is the following today. So there's 3 steps I need from everybody today. 3 steps. Step number 1, mark your diagram correctly. So that's what we're going to do first on every problem here. Mark the diagram. So we'll mark the diagram first. So let's talk. What could I mark any diagram with? There's a couple sets of markings we put in Unit 1. What could I mark any diagram with, possibly? I can mark them with? Nobody. We didn't learn a thing in Unit 1. I'm not calling on numbers just yet, so if you want to. Yep.
A box.
A box, which means right angles. Hash marks, which means segments are congruent, or Aisha? Arc marks, right? I can mark any of those 3. You're going to mark your diagram with what makes sense based on what I give you. Second thing we're going to do, we're going to make statements. I should say make true statements. Don't want them to be false. Make true statements about the diagram. All right, so we're going to make true statements about based on what you marked. Based on what you marked. What's true about the diagram. And then finally, and this is going to be the toughest part, and this is where I'm going to help everybody out today, is the why. Why are your statements true? It's going to be the tough part. Let's dive right into the fire honors, kids. Number 1, everyone see the triangle I'm providing you, ABC. Look at what I'm telling you about that triangle. Line segment AB blank, I'm not going to tell you that part, and BC. First, we have to know that symbol. Ready or not, hey, this is where I get fired up. Ready or not, you got to know what that symbol is. Now. Not in 48 hours, you got to know what it is now. I can't wait for you anymore. All right, we're not slowing down the train to review. I can't wait for anybody. You got to know what that symbol is. What is it? Perpendicular. All right, you know what the symbol is. I can't wait for you either to know what it means. Perpendicular. Too late. Game over already. Now, I need to know it now. Perpendicular, what are we thinking? 90 degrees. That brings me to the box we should be able to put on our triangle right now. That is number 1. Mark the diagram. I can't put hash marks, I can't put arc marks, but because I know what that symbol is and what it means, we can do that. So that's the first thing I want you to do today. Mark your diagram with what's true. You have no right to do this. Nothing up here says they're congruent. Don't assume it because it looks like it. If it doesn't say it, nothing. All right, so we marked the diagram with everything we could. Next step, write a statement that's true about the diagram. But we're not just going to write it in any of the white space we can find. We're going to be organized about this. We're going to organize our thoughts into 2 columns. The first column is going to be all the statements we think are true about the diagram. Second column, why they're true. That's going to be what we call reasons. And I'm having you do this from day 1. This is how we're going to set up our proofs starting Wednesday and throughout the entire year, with statements and reasons. Anything you put in the statements better be true. Better be true. Not an assumption, not what you think. Opinions don't matter here. Facts. Hashtag facts. All right, I want facts only. So we're going to start with statement 1. One thing we are guaranteed is always true. One thing we're guaranteed is always true. In this case, we are guaranteed that AB is perpendicular to BC. Guaranteed that that has to be true. And don't overthink this, honors kids. Why? Why are we guaranteed that that's true? Zane?
It's given.
It's given. And you know what? That's my reason. Given. So that's what I'd like you to put on every statement. Number 1 is whatever has been provided as the givens. And the reason it's true, it's given. All right, now it's time for you to take over. What did you just mark on the diagram? Because I need that marking to go here, but in symbolic, using notation in words now. What did we just mark on this diagram here? Now let's get nuts. What did we just mark on the diagram there? One job, B here. Where are we going with that one? Carter, what did we just mark?
The angle ABC is 90 degrees.
Okay, angle ABC. I don't like to write equals 90 degrees. I actually want to call it what it is, which is a right angle. Heads up, you are now going to see me use abbreviations. Whatever abbreviations I use, you are more than welcome to use them. So I'm going to say is a right angle. There's my abbreviation. I'm going to start using the abbreviations here. Feel free to use them. If you want to write it out in words, that's fine. Does everyone agree? That's definitely true. All right, tough part. Why? Why did anybody put a right angle symbol on B? Why did you do that? Not because it looked like it. Not because I told you it. Not because someone next to you did it. There was something up here that said you better put a right angle right there. What was it? What made us put the right angle there? In your own words. Liam? Because you knew what vocab word. Ready? Perpendicular. I'm going to use the symbol instead of writing out the word. Perpendicular lines form. Anybody want to finish it for me? Anytime lines are perpendicular, always will form right angles. Yep, I don't like using 90 degrees anymore. I want to call it what it is, right angles. So does everyone see? We translated our marking on the diagram to an actual statement. Get in that habit. Whatever you marked should go in as a statement. I'm going to drill one more out of you. And the only reason I'm going to drill this one out of you is because I know we're going to use it in proofs during the year. Before we mark the diagram, that was just good old triangle ABC. It was just a triangle. Now it's a specific triangle. And I want to write that into statements. What type of triangle is this up here? Now, don't overthink it. It was just triangle ABC, but then we did a little something there. And what type of triangle is this now, Jacob?
Triangle ABC is a right triangle.
Triangle ABC is now a right triangle. Correct. How does young Jacob back there know it's a right triangle? Again, don't overthink it. How does he know it's a right triangle? What's there for us there? Shreya?
Because line AB is perpendicular to BC.
Okay, keep going. I didn't know that would have made a right triangle, though. What made it a right triangle?
The measure of angle B is a right angle.
Right triangles? You got it. Have? What do right triangles have? That ours has. Right angles. Good. These are reasons we will be using all year, so please start using them yourself. Do not start making up anything on the fly. Use the reasons we have here. Questions? I'm going to stop there. I have a question, right? Is how were we going to know when to stop with this? Like, how many statements do you always want? Depends on the problem. If you look at your homework real quick, so I don't have to do this at the end, look at your homework real quick, starting on page 3. Does everyone see below every given, in addition to the givens, that's how many additional statements I want. All right, so when you're on the homework tonight, I'm telling you how many more I want other than the givens. All good? All right, here we go. Next up, one doesn't make you great. Let's keep rolling. Ooh, book. Okay. Read the given. Read the given. Look at the diagram. Mark something. Mark something. I know everyone's want to do statements, reasons real quick. I want you to mark your diagram first, please. Read. BD is the bisector of angle ABC. You should be able to put some markings on your diagram if, big if, we know our vocab. What type of marking are you putting on this diagram? Because we have a bunch of different markings, right? Mizuki, what are you putting on your diagram? Okay, I'll let that fly. Where are you putting them? Thank you. Oh, thank you for naming it with 3 letters. See what you did? 3 letters. Thank you. And? All right, you got it. Good work. So we should have markings there. No hash marks. Can't put hash marks on rays. Okay, we got the markings. Now we get our thoughts down in statements and reasons. Everything you put in the statements must be true. Has to be true. No opinions. Facts only in the statements. Facts. Well, we know one fact definitely true is always the given. BD is the bisector of ABC. And I know that's a true fact. I know that's a fact because it was given to me. Now take the markings and put them here, but in words, symbols, notation, right? Whatever we have there on your diagram, put it into notation, symbols for me. What did we mark on the diagram? Talk to me. What did we mark on the diagram? And I'll convert them. Savannah, what did we mark on the diagram?
We marked but I said that angle ABD.
Good. Okay, hold on. Angle ABD. Yep. Thank you. She used our big word, not equals. Big word, congruent to. Keep going.
Angle DBC.
Thank you. Perfect. Everyone see how we translated the markings into notation. And then here we go, the why. Why did every one of you, hopefully every one of you, put arc marks there in those specific spots? What up here in this problem told us that I was going to have 2 congruent angles? What up here in this problem told us that, Quinn?
ABC is bisected, which means that it's split in half. So that means that ABD and
I am not writing all that. Thank you, though. That is true. I'm anybody else writing all that? I need my Chromebook to type all that in. You know what a bisector is. The bottom line. Yes, you know what a bisector. So what I'm going to write is definition, and I'm going to write DEF for shorthand, a definition of a bisector, which is basically what I think Quinn just gave us right there, was a definition of a bisector. Perfect. I'm going to have one more, though. One more true statement. We're going to do one more. I would expect everyone to get number 2 out easily. Now here's number 3. I want number 3 written down because I know it's coming up and you're going to need this statement sooner or later down the line when we start proofs. Let's keep talking about angle ABD right here. Let's keep talking about ABD. I could also write DBC because they're the same. I want to compare it to the big angle, ABC. I know they're not equal. I get it. They're not the same measure. But I want somebody to put something into this that will make them equal. How do they compare? Angle ABD. How does it compare to ABC? Because I want to write that in there. They're not equal, so I can't leave that the way it is. How does it compare? Don't go by looks. Use your vocab, right? Use your vocab. Sophie, how do they compare?
Angle ABD is half of ABC.
You got it. Angle ABD is half the measure of ABC. Good work. Everyone ready for the why? Why a half? She could have said a fourth, a third, 2/3. Why'd she pick a half? Why a half? Kai?
Because it's been bisected.
Definition of a bisector. It serves two purposes. Cuts an angle in half, makes it into two congruent angles. Good job. Good job. I could also put DBC, but we're good here. Any questions from you guys from the two now? Mark your diagram. We're getting in this habit. Oh, such sad news, honors kids. If I had a heart, it would be aching right now. I give you M as the midpoint of BD, but what else is not provided? Oh, a diagram. And it's not a typo. Sometimes you might have to do your own. I'm so sorry that happened. Make your own diagram, please. M is the midpoint of AB and mark it correctly. Hopefully you're picking up on the sarcasm because I'm laying it on pretty thick. Hopefully we remember what a midpoint is, because if not, we're not going to be able to mark our diagram, or we're going to do it incorrectly. What are you doing on your diagram for me? Talk to me. What are you doing on your diagram, Shreya?
So I put point M in between points A and B, and I put hash marks on each side.
Where'd you put hash marks?
Between
Name them.
between points A and M and A or M and B.
Okay. Hopefully everybody else did that as well. Yeah. Yep. I don't want to say why we did that because that's coming up. So let's go to our statements and reasons. Go ahead, get in the habit. Your first statement we know is true is always the given. If anybody wants to join me, midpoint, MIDPT for an abbreviation. If you want to join me in doing that. If not, I'm okay. Second statement, put your markings into words and symbols. Put your markings into words and what was marked on our diagram, please? What was marked on our diagram? Carter, back to you.
One second A and M is congruent to one second M.
Thank you. All right, Shreya did it. I won't ask her because she knows the answer to this. Why'd she put hash marks on AM and NB? Why are they equal? How do we know they were equal? What up here said they were equal? Why? Jacob. There you go. Now we'll use, instead of bisector, definition of a midpoint. Looks good. And again, we are going to be using that reason through the entire year. I do want one more statement, and some of you may already know what it is if you saw what we did last problem with the angle. I'll do MB this time. I could do AM, either one. And I'm going to say that's equal to something with the whole segment AB. All right, they're not equal, but how do they compare? MB is what of AB up here? Sticks, Thora? Half, yes. And why did Thora pick half, not a third, not 2/3? Because we are dealing with a midpoint that cuts a segment into half. Please use the same reasons I'm using, right? Let's not start actually, well, a midpoint breaks a line segment up into two congruent parts and cuts it in half. I don't need to read that. Please, I don't want to read that. All right, just write definition of a midpoint. Any questions before we get to the tough one? Let's go. Spin a Rooney. Woo-hoo-hoo! Oh boy. There is no no vocabulary term that you can lean on here. There's no perpendicular. There's no midpoint, bisector, nothing. But it's possible. You should still be able to give me markings and something to tell me that's true about the diagram, even though I'm just telling you they're intersecting. That's not a vocab word, intersecting. But based off everything we talked about in Unit 1, there's some stuff in that diagram that is true without giving a vocab term. Where is it? Where is it? Anybody let's start here, markings. Anybody marking your diagram? Or something you think is true. Finn, you got something for me? I'm ready.
On angle WSI.
Whoa, go ahead, I got it.
Angle WSI is congruent to angle ESR.
Don't tell me why, because obviously you know that's going to be your classmate's job. That's true. Hey, you remember my big spiel at the beginning of the class? This is where we got to be. And you got to know why, too. This is where we got to be. Now, this is where we got to be. And I'm also going to do this because those two are equal. The question is why, which I'll ask somebody in a second. But for now, let's get our thoughts down. Start with the true given. Did I put an actual? Oh, I finally did this year. I put lines above them. All right, let's put those markings into the statements. Right? Tell me which angles are. And look, everyone see how I have two pair of congruent angles? You can put that in the same statement. You don't need statement 2 and statement 3 to say it. Put it all in the same statement because it's going to have the same reason for both. All right. So it's not wrong. If anybody's already getting ahead of me and doing statement 2 and statement 3, you can leave them. I'm just going to put them in the same one. Angle WSI congruent to angle ESR. And then angle WSE congruent to angle ISR. Yes. No.
It's right that they intersect at point S in Scala.
Did I? Sorry, I forgot point S. Thank you. It wasn't on my notes there. All right. Now I need a reason why. Go ahead, Joe. What type of angles are they? These are like a blue and an orange are adjacent. These are opposite, though. But I don't call them opposite angles. We had a name for them. We had a name. What do you got, Evan? We called them vertical. Okay, and now I know what many of you're trying to get ahead of me. I'm not going to put definition of vertical here. Because what that is, all that means is they're opposite each other. If you remember, you probably, actually, you know what? I'm going to bring it up just to show you. Let's see. Because I want actually you guys to see it instead of me just talking about it. There's a packet. Let me bring you to the day we did vertical angles. Oh, there it is. Oh, right there. There's the day we did vertical angles. Underneath it, I had you write a theorem, a fact about them. If they're vertical, what do you know about them? They have to be congruent, equal. That's what I want in the reasons. I don't want definition of vertical. I want the theorem we wrote down, which is vertical angles are congruent. Do not use definition of vertical angles. That's not, the definition doesn't say they're congruent. The theorem does. Also, is anybody losing self-respect right now because you spelled it C-L-E? Get some self-respect. C-A-L. Not barnacle. Vertical. Any questions on how we know I know that Some of you guys need to study up on those verticals. That's fine. I'm not done though. I want one more true statement, and you're going to give it to me. You should be able to give me another true statement about this diagram. It's not like the last couple where I told you what it was going to be and fill in the blank. You should, based on unit 1, you should be able to give me another true statement up there. Go ahead. What do you think you got there, Quinn?
Angle WSI.
Okay, hold on, everyone. He's talking about WSI just so you can see it easily. I'm just going to put a 1 at the angle he's talking to. And?
Angle ISI.
Okay, stop right there. He is about to tell me something about angles 1 and 2. Now, there's a lot you could tell me about angle 1 and 2, but I'm looking for something specific that I know we're going to use going forward. Do you want to finish your statement?
They're linear pairs.
They are linear pairs, correct. I don't want that, though. I want you to go above that. They're linear pairs, so that makes them blank.
Equal to 180.
Okay, I don't want the word 1. I'm making it difficult. I don't want the word 180. We got a bigger word.
Supplementary.
That's what I want. Everything he said was correct. Never going to use it, though, in a proof. But we are going to use angle WSI and, not congruent, and angle ISR. Yes, they're linear pairs. Yes, they're adjacent. Yes, they form a straight line. I don't care about that in proofs. What I care about is they are, and you can abbreviate supplementary, SUPP. And this could, I'm only going to do this, hey, only write that down once. We could have done it for 2 and 3, 3 and 4, 1 and 4. We could have wrote a bunch of supplementary angles down. Everyone ready for the reason? There is a specific reason why they're supplementary, I want. Not because they're adjacent. Not because they form a straight line. All true, but not what I want written down. He said it. He said they're linear pairs, but not I don't want definition of linear pairs. Anybody remember what we had here? Linear pairs are, what did we just say about them?
Equal to 180.
Stop with the equal to 180. Supplementary. There we go. Linear pairs are supplementary. Do not go on to the homework yet. I want to fill you in on a key piece of information. Anytime moving forward, what I mean by moving forward, the entire year. Anytime you tell me any angles are supplementary, 99% of the time, that's going to be your reason. Now, honors kids are probably thinking right away, what's the other 1% then? What's the other 1%? You want to know what the other 1% will be that they're supplementary? Probably because they're given. All right. If they're not given, this will be the reason why they're supplementary. Okay? All right. Everyone's clear on the homework. Mark your diagram if you can. Get it into statements. I tell you how many additional, the givens don't count, how many additional statements I want after the given. Work with people around you if you want. Move around, that's fine.